Okay, so today we're going to talk about the polynomial and rational inequalities quiz review. And so we're going to go ahead and start with problem number 1. Okay, so remember here, in order to solve this inequality, the best way to do it is to use a sign chart if you're not going to graph it. And in order to do that, we need to know where the zeros are first. So the first thing I'm going to do is find where the zeros are, and I'm going to do that by factoring. So if you factor this, you get x times 2x plus 3, and I'm actually going to set it equal to 0 because I want to find where the zeros are at. So here, my zeros are going to be the following. Okay, the negative 3 halves coming from setting 2x plus 3 equal to 0. Okay, I'm also going to make a note of the multiplicity. So actually both of these have a multiplicity of 1, which is an odd number. So they are both odd, which means when I when I go past the zeros, the signs should change. So I'm going to go ahead and set up my number line here to make my sign chart with 0 and negative 3 halves. And because of the multiplicity, I'm going to go ahead and make a note that both of these result in a sign change. Okay, so we got that down. And now for each of these areas here, I'm going to have a setup so that I can figure out whether the interval is negative or positive. And remember that our goal here is that we want to remember that we are interested in where it is greater than 0, okay, which is our original problem. So if I go ahead and pick a test point over here, and I pick, for example, negative 2, because negative 2 is less than negative 3 halves. So if I pick negative 2, I will have a negative number for x, and then 2 times negative 2 is negative 4, and negative 4 plus 3 is also a negative number. So in other words, a negative times a negative is a positive. So that region is positive. Then I go over here and I see that there's a sign change. So this interval will now become negative. And then the last part, we also have a sign change, so it goes to positive. So if I'm going to write my final answer, and I'll give you it both in interval and inequality notation, we are going to say, well, where is it greater than 0? Well, greater than 0 would be anywhere it's positive. So let me try and change my color here. So here it's positive as well as here it's positive, so I need to represent those intervals somehow. So what I'm going to say is for x, let me change back to the pen. For x less than negative 3 halves, or for x greater than 0, the whole polynomial here is greater than 0 for either of those intervals. Okay, and notice how I didn't include the or equals to bar because I'm not interested in where it's equal to 0. I'm strictly interested where it is greater than 0. Okay, and then like I said, you could also write it as follows. So I can say from negative infinity to negative 3 halves, not including 3 halves, union 0 to infinity, not including 0. So this would be my final answer. Okay, and again, I would technically accept this one or this one as long as you have both parts of each. Okay, so that is question number 1. Let's go ahead and look at question number 2. So number 2 says x squared minus 4 less than or equal to 0. So the difference with this one is a less than or equal to. And to start us off, I'm going to find the zeros. The easiest way to do that is to factor. And again, that means I'm going to set it equal to 0. This is a difference of squares, where 4 is a perfect square. The square root of 4 is 2. So I get x minus 2x plus 2. I'm going to set each one equal to 0. So my zeros are going to be 2 and negative 2. And so right away I can set up my sign chart here, which is just kind of a more informative number line. I'm going to label the 2 zeros I have. Note that the multiplicity here, again, MP I'm just using as multiplicity, is 1. And we know that 1 is odd, which means that for both of these I'm going to have a sign change when I cross that 0. Okay. And now I'm going to go ahead and use the test area, or the test points. I'll have one here, and actually for these I only need that one because then I know that the sign changes between here and then again here. So let's go ahead and pick, for example, negative 3. So if I plug in negative 3 to the factored version, I get negative 3 minus 2 is negative 5. So that's a negative number. Get my pen back, negative. And then negative 3 plus 2 is also negative. And a negative times a negative is a positive, so this region is positive. The sign changes, so this region is negative, and then the sign changes one more time, so this is positive. And if you look back at the original problem, we are interested in where it is strictly greater than, or I'm sorry, less than or equal to 0. Okay, so that's this region here, but I'm actually going to include the 0 values because that is where it is equal to 0. So my final answer is going to be the following. Negative 2 less than or equal to x less than or equal to 2. That's it. Okay. Or if you want to use interval notation, the included or equals to bar gets a bracket. So that would also technically be correct. Okay, let's move on to question number 3. So question number 3, where you're going to have to do some factoring by grouping here. This is question number 3. So if you remember factoring by grouping, I find two numbers that multiply to, in this case, negative 24, which is 2 times negative 12, and add to positive 5, which is right here in the middle. So if you think about it for a second, factors of negative 24, 6, 4, 2, 12, 1, 24, 8, and 3, and actually 8 and 3 are going to be what the factors are that I use. And specifically, I'm going to use positive 8 and negative 3. So I'm going to copy the first term, the last term, and have plus 8x minus 3x. And I like to make this a plus negative, just to avoid some confusion with the negative signs. I'm going to group these, which is where this process gets its grouping name from. The GCF for these two guys is going to be 2x, off with x plus 4. The GCF for these two is going to be, I'm actually going to take out a negative 3, and this is a negative 3. Let me fix that. Or, I'm sorry, minus 12. So if I take out a negative 3, I'm left with the same factor inside here and here, which is a good sign. It means I'm on the right track. Factor out x plus 4 from both terms, and I get this. Set each factor equal to 0, so that my zeros are negative 4 and 3 halves. So when I set up my sign chart, I'm going to have negative 4 3/2. And I'm going to go ahead and do my test points for the factored version here. So let me actually highlight the form that I'm looking at so you guys know what I'm talking about. So I am focusing on this form here, which is equivalent to the problem that we just started with at the beginning, but it's a little easier to look at because it's factored. So if I, for example, plug in -5, I will get -5 plus 4 is a negative number. 2 times -5 is -10. -10 minus 13 is also a negative number. Negative times negative is positive. I forgot to mention the multiplicity. Both multiplicities are 1, which is odd. So I know that there will be sign changes at both. Let me just make a note of that. Okay. So the sign changes, this becomes negative, and then the last one is positive. So when I'm trying to write my final answer, right, I am looking at where it is greater than or equal to 0, which is another way to say positive or 0. So that is these two regions here. So the way I'm going to write that is x less than or equal to -4, because at -4 it's 0, it is 0, or x greater than or equal to 3/2, again, including 3/2, because at 3/2 it is 0. And another way you could write that is the following. Infinity always gets a parenthesis. And these are union sign, which means or. 3/2 to positive infinity. So there is question number 3's final answer. Okay, and again, either form would be okay. So let's go ahead and look at number 4, which is where we start to get a little more interesting as we are looking now at rational polynomials, which are basically fractions involving polynomials, instead of just strictly polynomials like the first 3. Okay, the first 3, none of them were rational. This one is rational. So the only difference here is 1, the multiplicity rules do not apply. And 2, I'm also interested in where the function is undefined. So I'm going to make 2 lists here. I'm going to say zeros. So zeros is where everything is equal to 0, which in other words is where the numerator is 0. So this one's very simple. X equals 0. Let's set the numerator equal to 0. And where is it undefined? Well, that's just the vertical asymptote, which in this case is +2. So I'm going to set up my sign chart here. Now, since the rules of multiplicity don't necessarily apply to rational functions, I need to do a test point for each region. So I'm going to have 3 test points here, here, and here. So let's go ahead and do a point such as -1, which is to the left of 0. And I'm going to have a division now. So I'm going to have -1 is a negative number. -1 minus 2 is also negative. Negative divided by negative is positive. Then I'm going to do between 0 and 2. Again, the multiplicity rules don't apply necessarily, so I need to do a test point for each region. A point between 0 and 2 is 1, so 1 is positive. 1 minus 2 is negative. Positive divided by negative is negative. And if you pick one over in this region here, like 3, you have a positive divided by a positive, which is positive. So remember that here we're talking about less than 0. You'll never include these vertical asymptotes anyways. So let me just make a note that this is a 0 and this is an asymptote, so I'm going to say undefined here. Okay. So if I go ahead and put this in terms of the answer that I want, which is less than 0, it's not going to include any of the zeros, and it's definitely not going to include any of the asymptotes, or in other words, points of undefined. points of being undefined because you can't include those, because that's where you divide by 0, and we're not allowed to divide by 0. So my final answer is going to be, well, where is it? Less than 0. Where's the polynomial less than 0? And that is only in this region here. Okay, so I'm going to say between 0, get it back to between 0 and 2. Okay, or you can say 0 parenthesis 2 parenthesis. So there is your answer for that one. Okay, and then we have our final problem, which is also a rational function. So let's look at number 5, which says x minus 3 over, x minus 3 divided by x squared plus 7x plus 10 greater than or equal to 0. Okay, so I'm just going to go ahead and factor this right away. That's almost always your first step, your first approach to solve any algebraic problems. If you can factor, it usually reveals a lot of information. So two numbers that multiply to 10 and add up to 7 would be positive 5 and positive 2. So I'm going to take note of the zeros here, which there's only one, 3. That's where you set the numerator to 0. And then places where it is undefined would be the vertical asymptote of negative 5 and the vertical asymptote of negative 2. So I'm going to use all 3 of these pieces of information on my sign chart. This is a number line, so I need to put them in order from least to greatest. And then I'm going to use this factored version here to use some test points. So all of them will have this format. Let's just set this up. So for example, I can pick negative 6 in this region. That's a number less than negative 5. So negative 6 minus 3 is negative. Negative 6 plus 5 is negative. Negative 6 plus 2 is negative. A negative divided by a negative is a positive, times a negative is a negative. So this is negative. Let me make a note that this is a point of undefined. This is also a point of undefined. And this is a 0. Just so I'm sure to definitely not include these two in my final answer. This one I'm actually, I could possibly potentially include the 0 here, since I'm interested in the greater than or equal to 0. Okay, so we'll see that in a second. Let's pick one between negative 2 and negative 5. So like negative 3. Negative 3 minus 3 is negative. Negative 3 plus 5 is positive. Negative 3 plus 2 is negative. Overall, I get a positive interval. Next one, pick 0. 0 is an easy one. 0 minus 3 is negative. 0 plus 5 is positive. 0 plus 2 is positive. So overall, this is negative. And for example, 4, that's a number past 3. So 4 minus 3 is positive. 4 plus 5 is positive. 4 plus 2 is positive. So this is all positive. And so just like the other questions, I'm interested in greater than or equal to 0. So I'm just going to use my sign chart here. Just like the other questions, in the sense that I'm going to use the sign chart. And notice that it's greater than or equal to 0, so I'm looking for positive intervals. So that's here and here. And I'm actually going to include this 3 here because that is a 0, and I'm interested in or equals to 0. So my final answer will be the following. Between negative 5 and negative 2, or anything bigger than or equal to 3. Okay, again, or equal to for this one because that is where it is at 3 equal to 0. These two I can't include anyways because they are undefined. Okay, so, and then the other way to write this is as follows. Oops. I'm going to put a bracket there to include 3. So that is my final answer.